Right. So what we're going to look at first is a single array, a one-dimensional array. Okay. Now, when you have a list of items, all right, it is declared just by saying, if I did, for example, there, names equals, open those brackets, Ray, J, Harry, Arian, and Bob. All right. So if I wanted to pick a single item out of my array, all I need to do is call on that variable and then call on the position. So we can shout out here, what position is Harry in?
2.
Well done. Okay, that's good. You understood the concept there. So if I said print names and use square brackets, I'm using 2, and that's going to, at the bottom, print out the name Harry. Okay. If I wanted to then print out Arian, it would be 3. So we understand the concept of that. That's great. That pleases me as your teacher, all right? Now, the next thing I need you to understand is if I was to go through every item in the list, all right, that is a type of search. What was it? Linear. Remember, binary is when we divide, we find the midpoint. Okay, is the divide and conquer method. But what I need to do is a linear search on this. Now, there are a number of ways to do this. Why am I showing you this? Because you kind of need to understand this before you can look at two-dimensional lists. So if I needed to do a for loop, all right, I could go for I in range, all right, and what I'm going to do up here, I'll put the number in a minute, found in list equals false, okay? So I've not found the name at the moment, and I'm going to say name search term equals input. What name are you looking for? All right. Now, what we're going to do here, how many items have we got on our list? 6. 1, 2, 3, 4, 5, 6. All right. So let's see what happens if I put 6 in here. Print names. And I'm using I to reference the position. All right. So I run that. What name are you looking for? Let's go for Bob. Now, I haven't done the actual search yet. I just wanted to demonstrate that it would it would go through every item in the list. The other thing you can do is go for I in range, and I could have put in there len names. So if I run that, it's going to print every item it's on. Okay, so it's printed every item in the list. Now, why have I printed it? Just to demonstrate. But what I'm going to do is at each name, okay, I'm going to say, because it's going to go through each item in the list, if, all right, names I is equal to search term, then we're going to say found in list equals true. Run it. What am I missing from that linear search right now? Because at the moment, I've got my list of names. It's set at false. It's not found it. I've said the search term I'm looking for. It's gone through each item and it's tripped it if it's found. What am I missing? Thank you very much. And lots of time in the exam questions where students have lost the top marks in the written paper of the programming, they've not included the prompt. Read the end of the question. Often there is some form of output. So then I can do another if statement outside of that loop now, because that's been triggered, that says if found in list is equal to true, print name found, else print name not found. So if I run that, there are other ways of doing the Boolean. So let's see if that works. There we go. Because when it gets to that name in the loop, because it goes through every item, remember, I is the index. So for I in range, so for 0, 1, 2, 3, 4, 5. Okay, so it was going through every item in your list. If that position, so imagine I got to position 3 and it says if Harry is equal to whatever the search term I typed in, it's going to trip that Boolean there, okay? It's going to trip that so that we've got that changing from false to true. Now, outside of the loop is when you check whether it was in there or not. Why is that relevant? Because you're going to now need to apply that to 2D arrays, which are a bit more complicated. So I'm going to stop that recording, but use that as a way to set up the game that we are going to make in tic-tac-toe. All right. So I'm going to stop that one.